Okay, we are starting chapter 10. Let's zoom in here. Ooh, there we go. Okay, start off with fundamental counting principle. If decision M can be made in M ways, and decision N can be made in N ways, then together the two decisions can be made in M times N ways. So it says the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? You just multiply the choices. 3 times 15 times 8 gives me 360 cones. Wisconsin license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So 3 letters, 1, 2, 3, 4 digits. So first off, letters. How many letters are in the alphabet? 26. And then can you repeat letters? Yeah, it could be B, 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 whatever it is. So 26, 26, 26. Then digits. Think about digits. So you could go 0 through 9. So that covers all 10 digits. And again, you can repeat digits as well. And you multiply those suckers together. Get a very large number. There we go. Nick's science test has a section of 12 true or false questions. How many different ways can Nick answer these questions? So like question number 1, how many ways can he answer it? 2, either true or false. Question number 2, 2. ... keeps going. So 2 to the power of 12, because there's 12 questions, is 4,096 different ways that he can answer on true or false on his test. Okay, sample space of an event is must have cut something off here, that doesn't make sense. Sample space of an event is all the possible outcomes. So a sample space of flipping a coin. What are your options? Oh, you either have heads or you have tails. Rolling a dice. You could get 1, 2, 3, 4, 5, or 6. Sample space of drawing a card from a deck. Okay, so for cards, there's 52 total. There's 4 suits. They are diamond, heart, club, and spade. Something like that. Then it goes from 2 through 10, jack, queen, king, and ace for each of the suits. Factorial. So factorial is the product of all natural numbers n to 1. So for example, 9, you're going to go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply it all the way down. And if you know on your button or on your calculator there's a button for that, I press 9. If I press this math button right here, go over to PRB, 4th one down is that exclamation point. And it'll do all the work for you. Same on the other calculators. Come ask me, or you're going to have to plug it in. So 17 factorial of 11. So that's really like 17 times 16 times 15 times 14 times 13 times 12 times 11 factorial. All over 11 factorial. Because it keeps going down, so the 11s really just cancel out. So it's really just 17 times 16 times 15 times 14 times 13 times 12. Because the 11 on will cancel out. 0 factorial, you'd be surprised to know that that is 1. If you plug that in your calculator, you should get 1. Permutations, an arrangement where order matters. Order matters here. So here's your formula, and I'll show you the button on the calculator. N factorial divided by n minus r factorial. There's your formula. N is total number of ways. R is what you're choosing, that number, which will make sense in a sec. So how many ways can you arrange the letters in the word dinosaur? So dinosaur has how many letters? 1, 2, 3, 4, 5, 6, 7, 8. So permutation, the order matters. So if you, for example, if it was IDNOSAUR, that would be a different word. The order of the letters matters. So I'm going to do 8P8 because I'm using all 8 letters. Again, if you go to this calculator, 8, press the math button, go over to probability, P is right there. Oops, and I forgot to put that in there. Bless me. 8P8 gives me 40,320. 7 students are competing in a geography bee. How many ways can they come in first, second, and third? So it's different who gets first, who gets second, who gets third. The order matters here. So I'm doing 7P3 because there's 3 places. Again, you just go and plug that into your calculator. 7P3 gives me 210. 16 players on the baseball team. How many ways can the coach make a 9-player batting order? So order matters. 16P9. 16P9. Oh my gosh. 4, 1, 5, 1, 3, 4, 7, 200. A lot of different ways. 28 students in Miss Bertelson's homeroom. How many ways can the students elect a president or a student council representative and alternative? 28P, and how many roles are there? 2, just representative and alternative. And then you plug that in your calculator. Okay, permutations with repetition will be n factorial over u factorial. Well, u is my repeats. So this really only happens with words. So how many different 10-letter arrangements are possible using the letters in the word automobile? So there's 10 total letters. And then we have to go to our repeats. We have 1, 2 O's. So we divide it by 2 factorial. Because those O's, if they're switched, it doesn't look any different. 10 factorial divided by 2 factorial should give me 1814400. How many different 9-letter arrangements are possible with the word disappear? 9 total letters. Oh, we got 2 A's. Oh, and we have 2 P's. So we have double letters. You just keep multiplying them on when you have more than one. Nine, 0, 7, 2, 0. The other way to do this is combination. That's where order doesn't matter. So for example, if I'm going to go to Starbucks and I want to choose 2 friends to go with me, the order that I pick them in doesn't matter. They're both still coming. It just doesn't matter the order that I'm picking them in. So that one is NCR, and that one's n factorial over r factorial n minus r factorial. Again, you saw on the calculator, there is a button for it, so you can definitely use that. Natalie has 16 close friends. How many ways can she choose 5? So 16, choose 5. 16, do the C button now, 5, and she's got 43, 68 ways. Abby's adopting kittens from the pet store. There are 18 kittens. How many ways can she choose 2? 18 total, and she's picking 2 of them. 153 ways. 12 employees at the sub shop. How many ways can the man choose? 4 to work this Sunday evening shift. 12, choose 4, gives me 495 ways. So there you go. There's 10.1 for you.